Hello friends, this is lesson 17 and here we are talking about types of supervised machine learning. In previous lecture also we talked about supervised machine learning, but there we talked about regression models. Here we are going to talk about classifications and then the difference between classification models and regression models, and then we will take the example of logistic regression and classification metrics we are going to calculate, and we will give some examples for them. Let's see here. Classification models, friends. You studied about regression models. Now let's see what is classification model. So classification models are supervised models. When we say supervised models, you have to understand that these models also require what? Label data. We have to provide input as label data. Because it is supervised model, it requires label data that predicts label as two or more discrete categories. So the output for this is not continuous, but the output is discrete values. But in regression, if you remember that I will compare later, there we had the response was continuous, but here the response is not continuous, the response is categorical data. And it is a type of supervised model. If we say supervised model, so we need labels data, and through labels data the output will be in the form of discrete values, not continuous values or variables. Now let's have an example here. For example, if we want to find the result of a student, so the result in the form of pass or fail, it is nothing but, if it is in this form, pass or fail, yes, no, male and female, so that is nothing but classification. We need classification models for that type of response values. Correct, incorrect, true, false. If it is in this form, or we can say it is in this form, discrete values. So this is binary values. Discrete values like this means like classification. If you remember, so PhD we have, then master we have, then we have bachelor, then we have 12th standard, and for them we can assign the numbers like 1, 2, 3 and 4 like that, or maybe and some other like this order. For PhD we have 4, then 3, then 2 and then 1. So these are nothing but whole numbers, and whole numbers are called discrete values or discrete numbers we can say. So these are called discrete responses or binary responses. If the form of response value is in that form, so we need the classification models, not the regression models, because in regression we said they need continuous response values. Now let's see here the difference between them, then you can easily understand the difference. So the outcome, first let's see the output or the outcome or the response value we can say. Here if it is classification, we will be having discrete values, but if it is regression, there we will be having continuous values. Now the metrics, if you remember, in regression models we had different types of errors like mean absolute error, we had mean square error like that. So here we have classification accuracy, we have to find how the model is classifying the values, the percentage for that, the higher percentage is preferable. So here the algorithms which are used here, some examples, logistic regression we have, KNN is here, but there if you remember we had linear regression, multiple linear regression like that, those were the examples for them. So these are the common differences between classification and the regression. The other thing you have to remember here, this one, it predicts the discrete values or response values we can say. Now let's see an example for classification model. So the classification model what we are taking here is the first one, logistic regression. So logistic regression is nothing but it is a probabilistic classification model. So it is a classification model, although the name is regression, but it is used for classification model. So it is used as a categorical model to predict categorical responses. This you have to remember, friends. Regression. So logistic regression is a generalized, why it is called regression, that this may make you confused why it's called regression. So actually it is the general form of linear regression which is used for classification problems. So let's see here, it can take as its input any value from negative infinity to positive infinity, where the output is restricted to the values between 0 and 1. So here we have 0 and 1. The input can be anything, any number of features we can add, but the output will be restricted between 0 and 1. And there we have something called threshold value, and the threshold value for this is 0.5. So greater than that value 0.5, that will be considered as yes, and lesser than that value will be considered as no, or we can say true and false. If we say we have 0.5 greater than 0. Which is called the threshold value, greater than that is called as true, and lesser than that is called as false. That is why it is called classification model, and the value should be discrete, the response value. Now the metrics what we are calculating here, friends, classification models, we evaluate the model's performance. We have to check the model performance, and that is nothing but the accuracy of the model, and higher accuracy is preferable or desirable. Now what we are going to do here, we will be calculating the model accuracy, how the model is accurately classifying the values. And then we will talk about confusion matrix. This you know that, because confusion matrix is used for further descriptions of the model, like if you want to know the types of error, type 1, type 2, true values, negative values, true positive values, true negative values, false positive and false negative, all these values, accuracy and precision, how the model is precisely classifying the values, all those things. So for calculating all those things, we need the confusion matrix, and then we will be printing this one also, classification report. This is nothing but overall classification result will be printed, the average for each and every class it will be showing us. Now let's see here and see in the examples here. So important libraries I have imported here. Then we talked about the difference between these two. We said the classification predicts output will be discrete values, and here we have continuous values. Examples we give here like fail and pass, and here if you calculate the average or the salary of person, so that is response. Some examples algorithms like we have decision tree here, logistic regression, KNN, etc. And here we have linear regression, regression tree, or random forest, we can say. And then we say there is some difference between the matrix. Here we are calculating the accuracy, and here the number of errors or types of errors we are calculating. And these are the examples, some of the examples of classification models or algorithms here. The first one is logistic regression, naive Bayes classification. We have decision tree, random forest, KNN, and we'll be talking about one by one about these algorithms or models. Now let's talk about logistic regression. So logistic regression is a probabilistic classification model. As we said, it is used as a categorical model which predicts categorical responses. It means the output is in the form of categorical data, maybe 1, 2, 3, or maybe yes and no, true and false, like that, or maybe in the form of 1, 2, 3, like few numbers, whole numbers. You have to remember we use a set of quantitative features. The features are quantitatives, but here okay, variables to predict probabilities of classes membership. Then logistic regression is generalized form of, as we said, this one linear regression. So here see friends, we said it can take any number of inputs or features, but the output is limited to 0 and 1, if you remember. So in between we have 0.5, and this value is called threshold value. So greater than this threshold numbers, that will be considered as 1, and lesser than this one will be considered as 0. So through this threshold value, it can be easily predicted whether it is true or false, yes or no, or we can say okay, correct or incorrect, wrong, right or wrong, like that. Now here, this is the formula, this is the function 1 by 1 plus e to the power of minus sigma or whatever this variable is, then x. So this value is minus, if this is x is 0, so x is 0, so any number to the power of 0 becomes 1, 1 divided by 1 plus 1 is 2, and that is giving us the threshold value. And other than that, it will be giving us some values greater than threshold value or lesser than that value. Okay, let's have an example. And for an example here, I am considering the iris data set. So iris data set is a standard data set which is created by this person or a fisher. So this data set has 3 classes. We have iris setosa, we have iris versicolor, and we have iris virginica. So these 3 types of colors we have. In these colors or these flowers are differentiated through the weight and height of weight and length of the sepal and petal. Through these 2 features, the flowers are classified whether it is versicolor or whether it is setosa or whether it is virginica, through the length and weight of the petal and the sepal. This you have to remember. Now I have to import the pandas libraries here. It is important. Then I am reading the data set and I am going to print here. Okay friends, so this is the length for sepal length and sepal weight, and petal length and petal weight. So these 4 features are nothing but the input, and species, it has to identify the species or classify the species, whether it is versicolor, whether it is setosa, or whether it is virginica. And these species will be identified or classified through these 4 features. So these are the inputs and this is the response value. You have to know that. Now let's see how many species do we have here. We have 3 species. We have setosa, we have virginica, and we have versicolor. So these are in the form of text, so we have to convert them into some numbers, and we will be using mapping dummy variables, if you remember in last lectures. So we have to convert them to some numbers. I say, okay, iris setosa, you map it to 0, versicolor you map it to 1, and virginica you map it to 2. So then these species will be in the form of 0, 1, 2, 0, 1, 2, 3 values we have, and 3 species we have. Now they are all converted to the numbers 0, 1, 2, 0, 1, 2, like that. If you are removing this from here, you can see that 0, 1, 2, 0, 1, 2, 1 is not there, it is there in between. So you have to understand they are correctly converted. Okay, now let's see here friends. I have to create the model. So for model I am using scikit-learn. So from scikit-learn in linear models I am getting this one regression, logistic regression. So then I will split the data into training and testing data, if you remember. So first we have to create the features and also the response value. So the response value here is this one, the species. We have to identify whether it is setosa, whether it is versicolor or virginica. So this is nothing but the response value, and these are nothing but the features. 4 features we had: length and weight for sepal and petal. So these are our x values, the features in the form of data frame, and this is the y value, response value in the form of series, and then they are splitted into training and testing data. You have to remember testing size, I have said it is 0.2, means 20%. 20% of data will be going for test and 80% of that will be for training, if you remember, and the values are randomly selected here. So I instantiate the logistic regression here, I created the model and I have to fit the model here, the training data, and then I have to predict the values. Let me execute this. it is executed. So the model is created, and here we have the predicted values. And now for understanding this one, whether it is data frame or series, I have printed them here. 80%, if you calculate how much it is, 120. Total size was 180. Yeah, let me print it here, you will understand how many observations we have. Total number of observations we have 150 observations in 5 columns we have. So 20% of that, if you go, it becomes 30, and 80% of that becomes 120. And this is data frame, and this is the series. So data frames are nothing but the x values training and x test, and the y value training and y value test. These are nothing but the series. So now I'm going to predict. I will give a value here. How many values are required? 4 values, 4 features we have to provide. Sepal length, sepal weight, petal length, and petal weight. 4 values we have to provide. Then the model will see whether which flower it is. So I have given these values here, 4 values. Let's see. Yeah, the model predicts the value 2. The value 2 is nothing but the reference value for what? Here I said, yeah, Virginica. So this flower with these specifications or features is nothing but Virginica. This one. If you change the values, for example, to some other things, maybe it will be, yeah, it is 0 now. 0 means setosa. Okay, now let's see the classification metrics here. And for that we said we are going to calculate the accuracy of the model, and from scikit-learn metrics I am importing accuracy and confusion matrix and classification report, and then I am going to calculate the accuracy of the model. For accuracy of the model we have to give the y value and y predicted value. Y predicted value is nothing but it is predicted according to the x value. Here model is equal to y predict is equal to model predicts from x value. So it is predicting and giving us the accuracy of the model. So the accuracy of the model is the highest number we have to prefer. In this case for us it is 83%. The accuracy of model is 83%, which is good, not bad. Now we want to see here how it is, what are the tested value and what are the predicted value, how they are matching and how many errors we have. And for that, very simple, we can see these are the test x value and these are the y which are predicted. So we had 0, it is predicted 0, we had 1, it is predicted 1, we had 1 like that, but here we have one mistake or misclassification is performed. It was 1 tested but the model predicted 2. So this is one error, and let me see, this is another error, which is not, this is another error. So total number of errors are 5. These are the inputs or testing actual values, and these are nothing but the predicted values. Just I have printed them to understand a number of errors or misclassification. You know how many misclassifications we have? 5. And now we are going for confusion matrix. So for that, y test and y predicted I have given here, and let's see, this is the confusion matrix. How many classes we have? 3 classes we have. 0, 1, 2. 0 means setosa, 1 means versicolor, and 2 means virginica. So how many random actual values are taken? 11, and here 8 plus 5, and that becomes 13. And how many values here for virginica? It is 6. Randomly they are selected, and this is the confusion matrix, and it is a square matrix for them. Now we have to calculate from this confusion matrix. You can calculate many features or many metrics you can calculate. For example, if I want to calculate the precision for class 1, class 1 means versicolor, so this is class 1. Now let's see, 8 means number of true predictions, and this is false predictions. So let's see here, so 8 divided by this one, the column, whole column. If you are dividing this actual value, true value, divided by whole column, so that is nothing but the precision. and sensitivity, which is also called the recall, I'm going to calculate for 1. Again, this 8, which is this value, but here this time I'm going to consider the row, not the column, and that is giving us the sensitivity of the classification, and this is giving us the precision of the classification. And let me print that, and also I'm going to print the classification report, the whole overall report. Yeah, here for class 1 it is showing me the precision is 1. In here also, if you see, the precision for that is 1. Manually, if you're calculating, this is the way. Otherwise, if you're calling the report here, it will be printing you everything, the summary like this. So here the sensitivity, or it is also called the recall, how much it is? 62. 61. It is 61 point, if we round them, so it becomes 62. So here it is 62. And here is the model accuracy, and here also it is printing as the model accuracy. But other things are also here you have to know, friends. I'm going to explain them for you here. So this is class 1, class 2, class 3. How many classes we had? 3 classes: Setosa, Virginica, and versicolor. So for class 1, this is the precision 100%, recall is also 100%. So what is F score? F score is nothing but the average of these two values. So 2 into this value and to this value divided by the sum of these two numbers, so it is giving you this 100. How many observations are there? 11 observations according to this one, also you can see. And class 1 precision is 100%, but recall or sensitivity is 62%, and the average of these two, if you are getting, and that is called recall, 2 into 1 into this number and divided by the sum of these two numbers, and it is giving us this one. The same way you have to calculate for this one also. Class 2, which is nothing but Virginica, the precision is 55%, and then we have the recall or sensitivity is 100%, and the average of these two, which is called F score, it is 71 in number of observations and 6 number of observations. Let me show you the 6 comes from here, friends. See here we have 1, 2, 2, and that becomes 2. This is 3, and this is 4, 5, and one more is here, I hope. Yeah, it is here, one more here. So total number of these observations are 6. It is like that. And now if you want to go here, accuracy, you know that the accuracy of model is calculated manually. Also you can calculate that. So here macro average is calculated. What is macro average? Macro average, it is taking the average of all these values, like the precision. This is the average. It is adding these 100% plus 100% plus 55% divided by 3. It is giving us 85%. And the same way for this one, you have to 100%, 62%, 100%, you have to divide it by 3. It is giving you this one. And the same way you have to calculate for all. But here we have another average also, that is called weighted average. How to calculate the weighted average? The weighted average is calculated differently, friends. You have to, for the first class, if I'm taking this one, so 100% you have to multiply it with the weight. This is called the weight of that, 11 into this one, then 13 into this one, into this value, and then 6 into this value, in total divided by number of total observation, which is equal to 30, and that is giving you the value 90. Here I have calculated, friends, 1 into 11, 1 into 13, and 0.55 into 6. In total number of these observations what we have here, it is 6. If you calculate, it is giving you 91%. In the same way, for this also it will be calculated like that. For this also it will be calculated like that. I hope you understood about logistic regression and about how it is classifying, the difference between logistic regression, classification and regression. So here we talked about all those things, and we covered the topics, and we talked about the metrics, and we give the examples for each and every one. I hope you understood this.